Deriving rules for exponents. We'll be looking at the zero exponent rule, negative exponents, and the quotient rule. And we'll be looking for and making use of structure. A power is an expression represented by a base number being raised to an exponent. Base is the number that's being raised, and the exponent is the number in the expression that tells how many times a base is to be used as a factor. So we're asked to evaluate 2 to the 5th, that is a power, where 2 is the base and 5 is the exponent. We multiply 2 by itself 5 times. So 2 to the 5th equals 32. So if we ask you to evaluate powers, some of these will become common knowledge. You can memorize these. You can also work them out. These are the powers of 2. And now when I get to 2 to the 0 power, let's see what's going on. As the exponent goes down 1, we're dividing by 2. So 2 to the 0 equals 1. What if I ask for 2 to the negative 1 power? That's 1/2. 2 to the negative 2 is 1/4. 2 to the negative 3 is 1/8, and so on. Now 3 cubed is 27. 3 squared is 9. 3 to the first power is 3. So 3 to the 0 will be 1. 3 to the negative 1 is 1/3. 3 to the negative 2 is 1/9. 3 to the negative 3 power is 1/27. And we can do the same sort of thing for powers of 5, like 5 cubed. And let's start to generalize something about these powers now. Let's look for any number to the first power. So we can see that any number, based on these 3 examples, raised to the first power equals itself. How about raising a number to the 0 power? Any number raised to the 0 power equals 1, according to these 3 examples. When we raise a number to the negative 1 power, it looks like the number can be written as 1 over itself. Finally, let's look at n to the negative 2. A number raised to the negative 2 power can be written as 1 over itself squared. So let's simplify some expressions. We'll start with x to the negative 3. We're going to write that as 1 over x to the 3rd power. In the next expression, it's the negative exponents that we need to deal with. The x squared can stay in the denominator, but the y to the negative 4th, we have to change its place in the fraction. And so this expression becomes 1 over x squared y to the 4th. In the 3rd example, the 1 is fine where it is, but the w to the negative 4, I need to change the place of the fraction of the w to the negative 4, bring it up to the numerator. It becomes w to the 4th over 1, or just w to the 4th. So notice, to deal with negative exponents, to make them positive, you change the place in the fraction. If it was in the numerator, move it down to the denominator, and vice versa. Let's evaluate some expressions given a is negative 2 and b is negative 3. So we'll substitute negative 2 in place of a and negative 3 in place of b. Now, a negative times a negative is a positive 4. Any number to the 0 power is 1. So this simplifies to 4. Let's evaluate the next expression using negative 3 for b. And negative 3 squared is 9. And we'll just multiply across, and we get negative 81. So now you'll see something in books called the quotient property of exponents. And what we'll try to do here is derive this property. First of all, x to the 7th means x multiplied by itself 7 times. And x cubed, of course, is x times x times x. Notice we have things that will cancel out. And so we can rewrite this expression this way, or x to the 4th. Okay, let's look at another example. Remembering that we have to deal with that negative exponent and change its place in the fraction. This expression can be written as x to the 10th. So what we want to do is, in the first example, look at the exponents that were given and look at the exponent that resulted. And we can see 7 minus 3 is 4. That is also true in the second example. If we subtract 3 minus negative 7, we do get 10. So the quotient rule for exponents is some base to the m power divided by x to the n will equal x to the m minus n. So we can use this quotient rule to simplify expressions. And what we'll do is we'll look at our x terms and we'll put those together. So it will be x to the negative 5 minus 1 times, then we'll put our y terms together, y to the 6 minus 2 times z to the 1 minus negative 3. And then we will evaluate x to the negative 6 now times y to the 4th times z to the 4th. The x to the negative 6, we have to deal with that by putting it in the denominator. So whenever a problem asks you to simplify an expression, it's important that in your answer you only have y, z, and x written one time. Right, now this same example we could have simplified first using negative exponents. So change the place in the fraction of the x to the negative 5 and the z to the negative 3. So that becomes z to the 3rd, in other words, up in the numerator, and x to the 5th in the denominator. Now we can simplify this by bringing our y terms together, our z terms, and our x term. Okay, finally some practice problems for you using what we just talked about with negative exponents, with evaluating expressions, and with the quotient rule.